Okay. All right. How does that look in terms of lighting? I think it's fine. How do we all feel here? I'm going to turn down the lights a little better. I think that will help. There's enough sunlight that I think we'll be okay. If anyone has an issue seeing, though, let me know and we can figure out the lights a little bit better. Okay, Computer Science 263, Computer Architecture. Who here has heard anything about this class before taking it? Yeah, throw it all away because it's entirely different now. And the reason it's different now is because it's what it's actually supposed to be. I don't really know why, and this is not a sane effects issue. This is an everywhere issue. What this course is supposed to be, and what it's become over the decades has shifted quite far apart. I don't really know why. My guess is over time, computer scientists started operating in a much more abstract world where we're dealing with high-level programming languages and APIs all the time, such that when we start thinking of the actual computer hardware and transistors of how computers actually work, we're really far removed, and then you ask a prof who doesn't know what a transistor is to teach about it, they're left going oh. And so all they teach is assembly language, which is a crazy high level of abstraction over the hardware, which is a topic of this course, but it's always supposed to be the last topic of the course. And usually the courses are all about assembly with a little of the other stuff peppered in. So I'm resetting to what it's supposed to be. Because there was a time not that long ago, really, in the grand scheme of things, where what we're going to learn, is computer science. To be clear, this is computer science. But what I mean is, this would be the entirety of computer science. All right? Things like a programming language like C# or Python were light years away. So this is it's computer science. But we're going down to how does a computer actually work, though? We all know how a computer works. And then I go, do you really? And then you go, nah, I don't know. How does it work? How does it really work? You know? We might have some vague ideas of what's going on. But this course is actually going to show you. But we do have to start at a certain level of abstraction. The word abstraction tends to get abused a lot, so I'm going to help define it right now. Usually we talk about layers of abstraction. It's that game I play back in if you took 161 with me, it's that game I play of okay, who wants to, I need a volunteer, who's feeling brave? Okay, I'm in my kitchen and I want to make spaghetti. Tell me what to do.
How specific?
And therein lies the actual nuance of what I'm getting at. How specific do I want to be? Well, just try.
All right, spaghetti. Locate your pasta noodles.
How do I, okay.
Well,
What does that even mean?
well,
Right?
I don't know if you. I don't know.
You know what? Let's start with this. Let's start with, give me a very high level of abstraction, right? So when you say locate pasta noodles, I go okay, yeah, great.
Yeah, okay, you have them.
Grab a pot, fill it with water,
Put some salt.
boil it, a little pinch of salt, yeah.
Yeah.
Throw in the spaghetti. Do I break the spaghetti? Oh yeah, okay, there we go, okay. Don't break it, put it in, wait, 9 minutes, and I'm good to go, right?
Yeah.
That's it. That's a fairly high level of abstraction. If I tell you how to get to, how did I get to work today? Well, okay, I left my house, got in my car, and drove down the street, I could talk at a very high level, or I could be okay, step out of the door, lock the door, take steps towards the car, open the car door, sit in the car. But if I'm telling you, I don't need to explain it to you like that, right? You're okay, but this is detail I don't care about. But ultimately, those steps were there. Now, humans operate at a fairly high level of abstraction relative to, abstraction's a relative term, so yeah, relative to cell processes, exactly, and ion pumps, right? But I could take it further. I could be lift right foot, move right foot forward, put right foot down, lift left foot, right? I could describe it like that, and that's an even lower level of abstraction. And I can keep, okay, well, how do I lift the right foot? Okay, contract muscles. How do you contract muscles? Oh, boy. How do you do that? neurons firing. How do neurons, okay, well we have like potential differences, and then we have like ion pumps where ions are like we could play this game all the way down to like the atomic level, right? That's like the lowest level of abstraction, fine. So that's a very low level, but of course we don't start talking about how do I drive to work, how do I make spaghetti, talking about ion pumps. That's ridiculous. But they're there. They are involved. We are going down to a fairly low level of abstraction, like one of the lowest we can in computing. We could go lower. We could go all the way down to the atomic level, but we're not really going to. We're going to start with a little bit of assumed knowledge of electricity. Who here has a vague notion of what electricity is? Put up your hand. Yes, you do. Right? Okay, you're in great shape. You're in great shape. I'll make sure all the things you got to know about electricity, you'll know, right? We're going to talk about it at a fairly high level. And I will make, there are some like common analogies that people make or use when talking about like electricity and circuits that aren't really accurate, but are sufficient to get the intuition for what we're going to do. So I don't want anyone here who's taken first year physics to be like, actually, I know, it's first year physics, I know. Okay? Chill out, it's just an intuition example. What else do I want to say? Also, for those of you who are looking at this topic, you're like, well, that's physics. No, it's not physics. This course is not a physics course. We're talking about this topic isn't any more physics than it is computing. It's an intersection of these topics. It's where they overlap, right? Just because you learn about digital electronics and physics, it could just be a digital electronics course. It's just what umbrella does it fall under? Okay, things to know. Like my other courses, all the course content that is used to build this site is available on GitHub. You can download it. You can fork it. If you see a typo you want to contribute, I really encourage you to do it. Submit a pull request. If you don't know what that is and you're really curious, let me know and I'm happy to explain it to you. But if you contribute to the course website by fixing typos or adding details that feel like they're missed, I will be ecstatic. There are some guidelines on there. It's fairly straightforward. If GitHub feels like a big jump, I always tell people like, oh, I thought about contributing, but it's just too complicated to GitHub. GitHub is one of those things that looks like a mountain, and then you do it, and you're like, oh, that was like a baby step. Like it was nothing. It's trivial. Class time, you found it today. I'm sorry, 8:30. I had nothing to do with this. I'm going to be honest. I have a hard time with 8:30s. It's not easy. I get it. That's not don't be late. I'm just saying. It's tough, I know. Office hours, I believe these are correct. Tuesday, Wednesday, Thursday, Friday, note 12:30, 12:30, 1:30, 1:30. I won't be there today. I have to go to get my passport. Sorry. It's been booked for like a year. I don't know. It's a whole thing. Labs, there are labs. They are mandatory. And here's the course notes. The course notes, the course is not done. I'm still actively building it. I've got some lead time. Don't worry, by the time we get there, hopefully I have the rest of the content made. I've redeveloped the course, so the pacing, we're going to figure it out. You're a bit of a guinea pigs this year, but you'll be just fine. The labs, there will be a lab tomorrow, by the way. And if you go to the lab and you're like, there's nothing there, I know. Because I don't know what it's going to be yet. Maybe by tomorrow I will have this filled out. If it's tomorrow before your lab and you're like, he hasn't filled it out yet, still show up. I'll just tell you what to do and we'll figure it out. Okay? Again, you're the guinea pigs. I don't know what topic we're going to be talking about next Wednesday, right? Yeah. I thought that was a hand. Really quickly, let's go to the outline. Has anyone done this, the getting set up thing?
No. Click on the link and then that's it.
Okay. You can download, I'll show you. I'll show you in a moment. Computer organization. Okay. We learned the basic concepts of computer architecture, arithmetic, architecture, instruction sets, in-depth study of a central processing unit, memory, input-output organization, and microprogramming and interfacing. Really, it should also say assembly languages in there too, but whatever. Class times, labs, website. There is Moodle, like my 162, 161, if you've taken with me, or any other course you've taken with me. Moodle serves exclusively to have your grades, which I never weight because I never remember how. It's weirdly complex on Moodle. So if you look at your course grade and your final grade's wildly different, I know because it's not weighted, right? We'll come back to this in a moment. This website will have most of the stuff. Moodle serves as where to submit your assignments and where your grades will be posted, but ignore the final grade. It's entirely meaningless. It's not weighted. Topics, yeah. Student evaluation with tentative dates. That's a typo. I need to fix that. It's supposed to be 5, 5, 5, 5. I think I was saying yeah, total of the assignments was supposed to be 20, and the reason I had that is I wasn't 100% sure yet how many assignments there would be. My anticipation is 4, but I don't really know. If it feels like there should be 5, maybe it'll be 5. If it feels like there should be 2, maybe it'll be 2. We'll see, okay? But I'm envisioning 4. I think that makes sense. Each would be 5%, so, 5. 5, 5, 5, 5. Lecture and lab activities, more on this in a moment. Midterm, 30%, final, 40%. Heavy weighted on tests, because I don't trust you. All right? I'm sure you're the one honest person in the room, I know. Okay, assignments. There's probably going to be a 4, but if fewer than 4 are offered, the weight will be adjusted such that the total of the assignments will be 20% of your final grade. So don't worry, you're not going to lose any of that. Submissions, you submit on time. Do I accept lates?
Absolutely not.
No. Good. Correct. I don't accept lates. So they're always due at 11:55, okay, on Moodle. And it's 11:56 and you submit it. Does it get marked? No. Why? 6 is bigger than 5. Okay, so 56 is past 55, meaning it's late. Oh, it's only 1 minute. Yeah, that sucks for you, doesn't it? Right? Like, what's going on? How long do I play this game? Only 1 minute. It was only 4 minutes. It was only 7 minutes. You submitted 7 minutes and someone submits it 15 minutes late. Do I accept both? What about the person that's like, I missed the deadline. I guess I won't submit. So because they followed the instructions and didn't bother submitting, they get penalized, but I accept yours because you didn't follow the rules? No way. Where do I draw that line? 15 minutes, an hour? How about this? Instead of you guessing where that invisible, fake, imaginary deadline line is, instead of trying to figure out what that could be, let's just stick with what I said it will be. 11:55. There's no guessing. You want to know the best part? I had no one try to submit late last semester. All their other courses they do, but not mine. It's wild. Students can do it. And if you're but my internet wasn't working, then why did you? The deadline is not when you submit it. The deadline is when you can't submit it anymore. Don't submit it at 11:54. That's ridiculous. Don't stay up that late. Just go to bed at a normal time. You'll feel better. So no late assignments. Marking. There will be a TA that does the marking. If you have a question, obviously ask. If you have a question for me and I go, I don't know, I'll pass it to the TA because they marked it and they'll know. They were the one in the trenches and they have the context of everyone else's, right? I'll try to answer it, but usually it's better to go to the TA because they'll actually have an answer for you. But if there's a problem, like a disagreement or an issue, come to me and we'll figure it out. What else? Submit on Moodle, marking. There is a rule that if you want, if there's a big issue and you want a remark, it has to be within 2 weeks of when you get it back. Backups. Tests. Don't cheat, whatever. Yeah, whatever. Miss tests. There are no makeup tests. If you miss a test and you get an approved accommodation, the weight of your missed test will be moved to the final. There's no makeup tests. Do you understand? If you just miss the test and say, well, I'll just have the weight shifted to the... No. You have to have an approved accommodation. Labs begin this week. You're all second year now, so you understand it. It's wild how many times first years go like, but my math didn't start till next week, so you can't start first week. I don't give a shit what you're doing in math. It starts first week. So I'll see you tomorrow in lab, which is in this room, right? Yeah, cool. You don't need to have your own computer. You can use these computers, assuming you can log in. Don't ask me how to log in. I can't remember. You might find it better to just use your own computer because we're going to be using software and you're working on assignments, whatever. But if you like these computers, by all means. I will warn you, and I don't know if it's an issue with like my computer. My computer's pretty heavy duty that I have in my office, but it's running Linux, like these ones, a different distribution of Linux. It's still Ubuntu, but it's a little bit different. And I know that the simulation software that we use is, for whatever reason, on Linux, I find it's got like this like weird delay where you press a button, nothing changes, but like if I press something else to like add something to like the computer's buffer, it will change. So I have this weird thing where I have to be like, okay, I press a button and nothing happens, but if I press, for example, print screen, suddenly it works. It's weird. And I don't know if it's like an issue with the software running on Linux, if it's something with my processor specifically, if it's something with my specific distribution or some conflicting dependencies on my system, I don't know. But I don't have that issue on my on Windows when I run it on Windows, just FYI. I haven't tested on Mac. I don't know. I don't even know if it works on Mac, so good luck. Pardon? Yeah. Lecture and lab activities. Okay. There will be 10, let's say at least 10. But don't worry, by adding more, it's only good for you. Lecture and or lab activities. All right? Each one is worth 1% of your final grade. Okay? So if it's like, so if I offer 15, it'll still max out at 10 though. Okay? Right? Do you understand? Meaning that if you just happen to miss 5, whatever. But I'm aiming at 10. These will take place when I feel like it. All right? So if after like today, I'm like, today obviously we're not going to have one. And this could take place in a lecture or in a lab. And what I would do is let near the end of the lecture or near the end of the lab, if we covered something that I'm like, okay, this is like really important. Okay? I will be like, okay, everyone, we're going to do the lecture activity. You have 5 minutes or whatever to do this problem. The problem I give you, if you are here and you've been paying attention, will be designed to be trivial. Okay? It's not like a gimme, but it's basically a gimme. The point of this is, let me finish explaining and then I'll go off to why we're going to do it. I started doing this back in like 2015 at another university. I stopped during COVID because there were issues with it during COVID. I didn't bring it back. I'm bringing it back. It tends to be good. All right, the date and time of each activity will be determined ad hoc. That's a fancy way that's a Latin way of saying whenever I want. The activities may take place during lecture or lab. So all 10 might be in labs, or all 10 might be in lecture, or some combination of that. Questions will be related to important concepts covered in the respective lecture or lab. So if we talked about, okay, we did a full adder today. Okay, draw me a full adder, right? That's what I got to get you to do, okay? Answers must be written legibly by hand on a clean letter/A4 size blank paper. That's the normal piece of paper. No half papers. The number of times that students come to me and submit the half ones or say they submit the half ones and they're gone because they don't sit and they fall out because they're not, I'm at your own risk, okay? They get lost shockingly easily. So if it's not on full size paper, assume it's not going to, you're in trouble, you know? I'm not giving you paper. Students must have their own paper. And don't rip them out of freaking notebooks. Because when you do that, that annoying edge too also causes issues with other people's. It's really annoying. It's not just that, and then they get stuck together, and then people's it's a real pain in the ass. All submissions must include the student's name, student number, StateFX email, and date. I used to say also include the activity number, but we always lose track, so it doesn't matter. All submissions must be made by the student completing it. I don't care if you two are working together and you're handing his in too. No. You all submit your own. The reason for that is your buddy's not here today and you submit it, we got a problem. You only can submit your own. I don't care. I don't care. If you break your leg and you're sitting in the back, fine, wave me down, but you're going to be the one to hand it to me. And no waving me down unless you have a broken leg, though, okay?
You walk all the way to the back of the room.
I know, right? That's what I want to know. All right, you may not have it. Okay, yeah, don't submit anyone else's. Don't have anyone submit yours. If you violate this, you will get not only a 0 on the one you're submitting, you will get 0 on that whole thing. I'm going to assume you're cheating, right? I'm going to assume you're submitting your friends. I've only ever had an issue with this once, and I definitely went all the way on them to make it the biggest thing. And it counted as like a mark of academic integrity, just because they wanted to submit their friends that wasn't there. Stupid idiot. This was back at Western, so it wasn't a StateFX student. But still, imagine, like you get nailed on this and you already have like your strike of academic integrity. Oof. And you must submit it within the allotted amount of time. If I say you have 5 minutes and it's more than 5 minutes, will I accept it? No. 1 year it's only happened once. This was back when I was still new here, and people didn't know me, I guess. And a bunch of people didn't hand it in, and then they showed up to the chair's office saying like, he's so mean. And the chair's like, what did you do? I'm like, they didn't submit it on time. And then the chair laughed at the students. Like, what are you doing? It was late. I don't like lates. I won't accept lates. It's in on time or it's not in. That's it. Yeah, if any of these requirements are violated, a mark of 0 will be applied to the specific activity. So you submit a piece of paper that's the wrong size or something, you know, buyer beware, I'll get you. The only exception to this is if is this where I give you a 0 on the whole. Like, I don't mean like, oh, you missed out on that 1%. I mean, this whole 10% is now a 0. The highest grade you can get in the course is theoretically 90% now. These activities are open book. Yeah.
Funny thing I noticed is like obviously all the percentages add to 100%, but the highest mark you can like actually put on to our
is 99. I know, it's so stupid. That might change eventually because I think they're in the process. I think they've been in the process of like updating the system that we use, but it is weird that there's only a 99. I don't like it, but yeah, that is weird. But if you don't know what we're talking about, in the system that we submit our grades in, that like keep track of students' grades, the highest grade we can give you is 99. I can't give you 100. It's not an option. If someone got a 100% in the course, they can't get 100%. They'll get a 99. It's so stupid. I hate it. Okay, yeah. The activities are open book. You can work together. In fact, I encourage you to work together. Collaborate and share ideas. You may check the course content. Most of the time, the question will be like, what is my name, right? Oh, it's literally right here. Like you just copy it from the course website. Maybe a little twist to it, right? It'll be a little bit more involved than that. Like if I give you 5 minutes, it'll take you probably a couple of minutes. But it'll be something that like you can look and be like, oh, there we go. All submissions must ultimately be done individually. You must be the one writing it down, okay, and submitting it. The point of these things are, one, it gets you here. You know, I always had the philosophy of like, I really don't care if you don't show up to class, if you're doing well. And I've had that philosophy for more than a decade. And then finally last semester, I kind of hit that like crossover point of where like, well, people aren't coming to class, but they're not doing well. So we got a problem. So Let's get your butts back in here. It gets you here. It gives me, when I give you a question, it gives you a signal like, hey, this is a big idea. 2, it gets you engaged with the content we just learned. 3, it gets you to like do that big idea. And it also gets you to like write something. Now in this particular course, maybe it's not as obvious because there will be some like writing and drawing for the assignments that you're doing. But imagine this is like 161 and 162, right? Usually by the time of the exam, students will be like, but I've never written code by hand before. Well, if you were doing these activities, yes, you have, right? We write code by hand all the time. There again, like the tests, there are no makeup activities. You miss an activity. If you get an accommodation, I will shift the weight of that activity for that particular one to your final. If you get an accommodation. There's no like, well, I missed one, just shift it. Where's the accommodation? You need that accommodation. Okay? Cool? Cool. Email contact. Of course you can email me with questions, but remember, there are questions that are fine for email. Those are ones that I should be able to look at and like answer quickly. If it's something that would take me more than like a few minutes to like respond and answer, that's an office hours type question because there's obviously nuance. This stuff is not trivial. This stuff, questions that I can answer trivially, I will do via email. Happy to do so. But anything that's like, okay, well, why with the full ladder was it designed like this instead of using another or? That's an office hours question. Like, come to office hours, happy to have a chat. Office hours are woefully underused. And like the attendance over the years has like just plummeted. My office hours used to be like, never when it was here, but like back at Western, back at Brock, my office hours were, I would have to like set a time limit because I'd have a lineup of people down the hall. There was a queue. And I'd have to be like, there's 20 people here, and I have 1 hour. So we had to do some math, right? So now I'll have less than 20 people all semester. Come to office hours. Like everyone's wondering, why don't they come to office hours? And then course evals, he was never available. Okay, fine. Come to office hours. Come to office hours. Attendance, it's necessary. Copyright policy. I own everything in here unless stated otherwise. You cannot record me. You cannot take pictures of me. Don't do it of anyone else in here either. But don't worry, I record myself. Statement of academic offenses. Okay, don't cheat. We'll check if you're cheating. You can get a tutor, but be careful. Accommodations, boilerplate. Look, if you're in second year and you've been dealing with accommodations, you know all the details here. Scent policy. Don't put on a lot of scents. It makes me like nauseous, and other people too. I can prefer support, health, wellness, a lot of boilerplate stuff. Any questions about that general stuff there? Yes?
These approved accommodations, are they from you?
No. You got to go through, I'm not 100% sure how it works, but so there's like the Tramble accommodations, that's a different thing. And then there's like an accommodation of like, I needed an x-ray the day of the test, right? Okay, there is a system in place on how to go do about it. You go through like the VP student something or other. Yeah, that sounds about right. They used to be Associate Dean of Academic Affairs, and then they changed the title. I think that's how it goes through. It's Kathy McDonald's office, yeah. That's how it goes through. If you ask me, I'll be like, no, talk to Kathy, right? It's her office. She deals with it all. Other questions? Questions. All right. Just as a quick thing, if we do go to Getting Started, and you go to this link, and you scroll down, this is the GitHub page. So you can clone this whole repo if you want, and if you're familiar with GitHub, great. If GitHub is intimidating to you, you just go to this website and you scroll down, and there's going to be a giant button that says download. Now, I know this looks like one of those download buttons on those super sketchy websites. This is weird, I know. This one's actually legit, okay? And all it does is you can even see here, it's a digital.zip, okay? So it's a compressed folder. It's just a folder, all right? So you click that, you download it, and you uncompress it, and I have an uncompressed right here, and this is what you would see, okay? Raise your hand if you are, here, let me really quick see. Does it say anything like Mac? Aha, on Linux, start the shell script, and on Windows and Mac OS, the jar file can be started directly. All right, so, okay, look, maybe you can just double click the jar. I don't know, on Mac, I don't know. I don't know. But if you have a Mac and you download it, try it. Let me know. Raise your hand if you're using, like if you actively use, like your main computer that you're using is Linux. No one. That's fine. But if it was, you know, you would do something like, imagine this was bash. You would just do like, you would just run the script and hit enter and it would load. This isn't going to work on Windows. On Windows, raise your hand if you use Windows. Great. This is the easy one. See the digital.exe? Boom. We're there. Wait, we're there. And say, hey, there's a tutorial. You can do it if you want, whatever. And this is it. This is the simulator. Okay? By the end of this course, I'll come back to this. This is it. If you're on Mac, it said something about running the jar. Maybe you just double-click the jar. I don't know. Oh, you can do it on Windows too. There we go. Cool. You could do the jar. Presumably, that would also work on the Mac. So there you go. That's all you need. This is the simulator. It's free, and it's really good. So usually, like the way the course used to be taught, you'd be taught all of these, like, you know, sprinkled in ideas of how does a computer work, transistors, logic gates, and all this type of stuff we're going to learn. And then you'll jump to assembly language. Assembly language is when you type like, you'll see. It's a low-level programming language. It's one step above typing like 01001, 011000111. Well, that said add two numbers together, right? Like it's one step above that where you say like add register 1 and register 2, right? That's like the level of detail. Load data from memory address whatever into register 1, load data into memory address whatever into register 2, add those results, store it into memory address Z, and yada, yada, yada. That's how you would write programming, very low level. That type of programming I love. And here's why I love it, is because like I give you Python and I tell you to solve a problem. And then, you know, if you're used to Python, you're like, well, okay, there's a lot of libraries out there. There's a lot of built-in functions. I don't know what I didn't want to reinvent the wheel, right? And there's all these different things I can do. When you're given assembly language, like depending on what type of assembly language you're using, like a simple one that would use for something like this course, you might have like 16 instructions. You literally have 16 operations you can do. And in theory, with those 16, you could do literally anything. So there's no guessing. Like you really got to start and solve these problems as simply as you can, which is, it's a lot more like puzzly to me in a fun way. But that's like assembly. Assembly is 1 degree higher level of abstraction than what we call machine language. Machine language is like the 010011111, which really, there's no zeros and ones really. It's low voltages and high voltages. There's no zeros and ones in a computer. It's just, is there a voltage difference there or not? Which mean we interpret as zeros and ones. A big theme of this course is the meaning of data and information. What is it? Right? That's a number. Was it a number or was it? You'll see. To go from an assembly language to machine language, we have something called an assembler. It's kind of got the same idea of a compiler, but a compiler takes a language like Java, let's say C, and turns it into machine language. An assembler takes a language like an assembly language and takes those and turns it to the zeros and ones. Assembly language really is just a bunch of takes. When I say add, it means 0101. I made that up, but like it means 0101. And register 1 is 0001, and register 2 is 0010. So the machine language would be 010100010010. Right? And if you're like, wait, what? Don't worry, we're going to get there. But the point is, it's a very simple step. A compiler will take it from a high-level language to the machine language. In fact, if you're using like a standard C compiler, what's really neat, and we might do this depending on how the course goes and how it flows. Maybe not this year, maybe I'll do it for a next version of the class or something, again, seeing how it goes. You can take a language like C, and when you compile it, you can actually compile it to the assembly language. And then and so you can actually see what the assembly language is, which is pretty cool. So in this course, we're going to work our way up to at least assembly, but we're going to start with transistors. That's a big gap. But it's shockingly simple because computer scientists are stupid. We can't do anything complicated. Everything we do needs to be the simplest little thing possible. And we build these simple things on top of each other to do complex things. But I can't explain the complex thing. I got to start down here, and we can work our way up because we're stupid. Okay? Don't try to be smart. Huge mistake with this stuff. Okay. Any questions? Digital is the simulator. What we're going to do in digital, eventually, we're going to work our way towards, we're going to start with transistors, and we are going to build a fully 100% Turing complete working computer in our simulator. We will simulate a fully fledged working computer. It's going to be a simple one in terms of, like it will have some constraints, but it will be Turing complete, meaning it is a sufficient computer, meaning it could play Doom. Okay? We're not going to get there, at least not this year, but it will be a fully simulated computer that we will program our own assembly that we invent together on this computer. Okay? Pretty cool, I think. I don't think you're going to find a version of 263 in the world that does this. Meaning, I legitimately think you're going to have the best version of 263 that has ever existed.
Pretty high praise for yourself.
I know. Look, that was my low sales pitch, too. You should hear the real one. Okay, cool? Yeah? All right. Now, oops. Okay, so that's the getting set up. All right. Intro. All right. Before anything, read the outline and get set up. What are you going to learn? Well, the purpose of this course is really, wait, what is a computer? Okay? We all know what it is, but as soon as you're asked, like, okay, explain it to me, we're all kind of like, what is computation? It's, you know, when you do things with the computer, right? Like, what is all this stuff, right? At the end of the day, we're going to start with transistors and basic electricity, okay? Electricity, people often use like the water analogy. It's not a great analogy, but it's sufficient for getting the intuition. Water wants to flow towards the ground, right? If I have water up here, and I just have it like in a bucket, and I dump it, it goes down. It wants to go down, right? The higher it is, like it wants to go down. Right? We have ideas like voltage and current and resistance. These are ideas that we're going to talk about very loosely, briefly, before we just kind of move on and we assume we have a sufficient idea. And we're going to be talking about transistors. Transistors, if someone asks you, what is the greatest invention of all time? Transistors better be at the top of your list somewhere. They are what it's all about. And they're shockingly simple. They are so simple. It's effectively a switch. Okay? It's just a little switch. It's a switch we can control something with. But what's neat about transistors is we can have systems control themselves, which is always kind of where when something becomes self-referential, that's always where things get interesting. But we're going to talk about them in more detail. But transistors are one of the greatest inventions of all time. And they're a bit of a hack of nature. There's like a joke of oh, what's a processor? We tricked rocks into thinking for us. It's a joke, but it's kind of what we did. This is really a transistor is like a hack of nature. We did shit with rocks to make them work the way we want to, and now we have computers. That's kind of what happened, right? It's a bit of a joke, but also effectively what it is, what happened. I'm not going to teach you how they are built. That's beyond the scope of this class. There are some YouTube videos I linked that are like 10 minutes long that are really well explained by a guy named Ben Eater, who is phenomenal. And I've actually spaced a lot of this course off Ben Eater's content that he's got on YouTube that you can watch through yourself. But anyways. Transistor. Here's a collection of 4 different transistors. Here's an itty bitty one. Here's another one. You might have seen these ones before. I've got these ones. I've got like piles of in my office for whatever reason. Here's a different type of transistor. Here's another, whatever. They're just transistors. They're very simple little things. This, I can't remember what they're called. Transistors can get really small, very itty bitty, okay? There was a time where transistors were such a buzzword that if like you had like I had a transistor radio, that was a big deal. Right? Well, I have a 4 transistor radio. Oh boy. Wow, I have 8 transistors. What do? Don't worry about it, but there's 8 of them in there. And that means it's better. There was a point where this was a big deal. Where now we're like, what's a transistor? Who cares? Whatever. I want to go on Facebook. That's the world we're in. But anyway, here's some transistors. There are several layers of abstraction that will be covered in this course. Transistors, logic gates, latches, registers, memory, addresses, ALUs, combinatorial and sequential logic, control logic, CPUs, architectures, machine language, assembly language, and compilers. Compilers will be like an addendum type thing. That's a lot to cover, okay? Before, when we were talking about abstraction in like 161 or 162, it would be like, I made a data structure called a queue. We're like, what a layer of abstraction that is. Well, yeah. But I mean, that's like Bush League compared to this. This is wild. This is huge, the layers that we're going to be going through. Fortunately, each one, like I said, each one is very simple, not trivial. When I say simple, I don't mean trivial. Trivial means like it takes no effort to understand. It's simple. It's going to take effort to understand, but it's not overly crazily complex, okay, or complicated, let's say. So they're simple. It will take effort to understand them, but they're 100% understandable. And as we build on them, assuming sufficient understanding as we go, they're going to remain simple. But like anything and everything you've ever learned that's cumulative, if you don't understand this, you ain't going to understand that type thing. So it's important that we, keep up with what we're learning. So here's a high-level idea of what we call the von Neumann architecture. And this is the architecture that most of our computers that we use today, including the one we're going to be using, or we're going to be designing, this general high-level idea of, okay, we've got this central processing unit, a CPU, and that interacts with like memory, and we have some like input devices to the computer, and some output devices. Input devices will be like a keyboard and a mouse. And output would be things like a monitor or sound, right? So that's how we interact with the computer. And by the way, inputs and outputs are weird, right? As soon as you have inputs and outputs, the systems become very side effect-y, which is not necessarily a bad thing, but it does add some complicatedness. But of course, we need input-output in order to interact with these things. But, this is a concept that will come up. But we have our control unit, ALU. This is the thing that's going to be doing all the number crunching. We have memory. That's like where data is stored. We could take it some steps back and be like, well, we have long-term storage, like a hard disk drive or an SSD, and then we have like our RAM, and then in there we have a register. There's a lot more to it, don't get me wrong, but this is a high-level view, all right? And this is the general design of how all our computers work. It is not necessary that a computer follows this design. There's a reason we conform to this one, but it's not necessary that we do. There are other designs that exist. In fact, there's another popular one called the Harvard one, where you have actually memory is separated, which is really interesting, and there's a lot of value to this. There's pros and cons, like anything. There's no free lunch. You win some, you lose some. Pros and cons to each. Where we actually have 2 banks of memory, one's for instructions and one's for data, which is really interesting. But there's pros and cons. But this is called the Harvard architecture. There are more. We could invent our own and we can make it work. But, some really smart people decades ago put a lot of thought into this and we usually go with this one. All right? By the way, von Neumann, who's heard that name before? That's so sad. Because again, if you say who is one of the most important humans to ever live, this person better be in the top list, in like your top 5, top 10. Big deal. You should feel terrible about yourself. All right, resources. Okay. This course is going to only really require one special. Oh, by the way, there is technically a textbook for this course. There is though, okay? One real resource we're going to be using is digital. I will also be making use of Python to generate some text files automatically for me. So if you have Python, which presumably you do, and if you don't, just go to Colab and suddenly you have Python. To generate some like scripts. I have some scripts to generate some text files for me that make things easier. Otherwise, I'd be writing like thousands of lines of zeros and ones. I'm not doing that. But we have a free simulator software called Digital. It's available on GitHub. I already showed you that. And you make systems that look like this, okay? So here's a screenshot of a modified version of an 8-bit computer that I made in Digital, okay? Ours is going to be a simplified version of this. When I say simplified, I don't mean I made it like easier, really. I just mean like I went out of my way to use like integrated circuits chips in this, which are in. I use more abstract components for what we're going to be doing, which is a good thing. But anyways, digital, it gives us a lot of power. We can do a lot of crap and build a whole working computer and run it on our computers, which is really interesting. And other resources. The course has recommended resources. I'm also going to, for the most part, a lot of them aren't done yet. There's going to be like recommended like readings for the end of each topic or videos for you to watch or whatever. And we're out of time, so we'll just stop here and we'll pick up here tomorrow? No, Thursday. Thursday, yeah.
Yeah, I think so. 8:30. That's the 8:30.
Tomorrow? Well, tomorrow we have lab. Yeah, we'll figure something out. All right, any last questions before we wrap up for today? Yeah.
There's another software that I used in my 221 like electrical circuits class.
Yeah, you don't want to use that one. Oh. All right, cool.